June 4, 1942. Flight deck of the USS Yorktown. The steel deck plates of the Yorktown are vibrating so hard they rattle the teeth of every sailor on board. It smells of unburnt aviation fuel, salt spray, and cold sweat. The air is heavy, thick with the humidity of the Central Pacific and the absolute certainty of violence. The engine roared. 14 cylinders, pure aggression. Lieutenant Commander Jimmy Thatch sits in the cockpit of his F4F Wildcat. He grips the stick with a gloved hand that is already slick with perspiration. He isn't sweating because of the heat. He's sweating because of what sits on the horizon. 200 miles to the northwest, the Kido Butai, the Imperial Japanese Navy's strike force, is turning into the wind. They are the apex predators of the ocean. They haven't lost a single fleet battle since the war began. The math is a death sentence. The Japanese A6M Zero climbs at 3,100 feet per minute. It has a range of 1,600 miles. It can turn inside a phone booth. Thatch's Wildcat climbs at barely 2,000. It is 1,500 pounds heavier. In a turning fight, the laws of physics say the American dies 100% of the time. But Thatch isn't looking at the enemy yet. He is looking out of his canopy at his own wings. They look wrong. They look broken. Just minutes ago, those wings were folded back against the fuselage like a dead bird, twisted at a sickening, unnatural angle. A mechanic had cranked a handle, swung them out, and inserted a single steel pin to lock them in place. It looks like a damn accordion. You expect me to trust my life to a hinge? That's what the pilot said in the mess hall. They trust solid spars. They trust rivets. They do not trust a hydraulic joint designed by a man who spends his days behind a desk on Long Island. To a combat pilot, complexity is the enemy. Complexity gets you killed. But looking down the deck, Thatch sees something that shouldn't exist. Squadron count. 27 aircraft. Deck capacity standard, 18 aircraft. Overload, plus 50%. There are too many planes. By all conventional naval doctrine, the Yorktown should not be able to launch a strike force this size. The deck is too short. The hangar is too narrow. Yet here they are, a swarm, a wall of aluminum packed shoulder to shoulder, made possible only because their wings fold into nothingness. The signalman drops his flag. Thatch slams the throttle forward. The Wildcat lurches. The broken wing shudders under the torque of 1,200 horsepower. He has 300 feet of runway before the ocean swallows him. If he doesn't hit 85 knots, he sinks. If the locking pin shears under the G-force of the launch, the wing folds up, and he cartwheels into a fireball. He doesn't know it yet, but the survival of the United States Navy isn't riding on his guns, or his courage, or the Admiral's map. It is riding on that hinge. If the pin holds, they have a chance. If it breaks, the war is over. To understand why a paperclip mattered, you have to understand the terrifying arithmetic of 1941. In the dimly lit war rooms of Washington, admirals pushed wooden blocks across giant map tables. They were playing a game of numbers, and they were losing. The Pacific Ocean is 63 million square miles. The flight deck of a Yorktown-class carrier is 800 feet long. It was a needle in a haystack, but the needle was on fire. The U.S. Navy had built these floating cities, the Yorktown, the Enterprise, the Hornet, with a specific doctrine in mind. They were designed to project power, but there was a fatal flaw in the blueprints, a ghost in the machine that no amount of polish could hide. The flaw was geometry. A standard fighter plane, the F4F Wildcat, has a wingspan of 38 feet. Parked wingtip to wingtip, a carrier hangar deck, the garage below the runway, can only hold a finite number of aircraft. It's a sliding tile puzzle made of high-explosive aviation fuel and aluminum. If you pack them too tight, you can't move them to the elevator. If you can't move them to the elevator, they don't get to the roof. If they don't get to the roof, they don't fight. The Bureau of Aeronautics, known as BUAir, was run by men who loved manuals and hated surprises. Their Red Book of Specifications was the Bible. It stated, in no uncertain terms, that a carrier fighter needed to be robust, heavily armored, and reliable. They wanted a flying tank. They got a brick. The F4F Wildcat was a tough machine. It could take a beating, but it was heavy. It was slow. And most critically, it was wide. The early models, the F4F-3, had fixed wings. They were solid slabs of metal bolted to the fuselage. Once you landed, that plane took up 1,140 square feet of deck space. It was a space hog. U.S. Navy Doctrine, 1941. Carrier capacity, approximately 72 aircraft. Fighter complement. 18 Wildcats, bomber and torpedo complement. 54 aircraft. Look at those numbers. 18 fighters. That is the combat air patrol for an entire fleet. Against a small, probing force, 18 is fine. Against the Kido Butai, it's suicide. Across the ocean, the engineers at Mitsubishi weren't restricted by American safety standards or heavy armor requirements. They had built the A6M Zero. It was like fighting a ghost. You see him, you turn, and he's gone. He's behind you before you even know you're dead. The Zero didn't just outperform the Wildcat, it humiliated it. It weighed 3,700 pounds empty. The Wildcat weighed 4,900. The Zero had a wing loading of 22 pounds per square foot. It could turn on a dime. The Wildcat needed a football field to bank, but the killer variable was the exchange ratio. In simulations, 1 Zero was worth 1.5 Wildcats. This created a tactical deadlock. To defeat the Japanese fleet, the U.S. Navy needed to change the math. They couldn't make the Wildcat lighter. That would mean stripping the armor and self-sealing fuel tanks, which meant dead pilots. They couldn't make the carriers bigger. Steel hulls take 3 years to build. The only variable left was quantity. They needed to swarm. Instead of sending 1 Wildcat to fight 1 Zero, they needed 2. They needed the thatch weave, a defensive tactic where 2 planes cover each other's blind spots. It was a brilliant strategy, but it required double the inventory. The logistics trap. To execute the thatch weave, the carrier needs 36 fighters, not 18. But the hangar deck hasn't grown. If you load 36 fixed-wing F4F-3s, you displace the dive bombers. If you lose the bombers, you can defend the ship, but you can't sink the enemy. You are a floating shield with no sword. The Bureau of Aeronautics knew this. They weren't stupid. They had tried folding wings before. The TBD Devastator torpedo bomber had wings that folded, but they folded up. Straight up, like a deeper surrender. The overhead fold was a clumsy, inelegant solution. It required a hydraulic system that leaked fluid all over the deck. It required massive overhead clearance in the hangar, meaning the ceiling had to be higher, which made the ship top-heavy. And worst of all, it required a ground crew of 4 or 5 men to muscle the wings into place if the hydraulics failed. Which they always did. A folding wing is a broken wing waiting to happen. You cut the spar, you cut your throat. That was the consensus among the pilots. They viewed the wing spar, the solid beam running through the aircraft, as a religious object. You do not cut the spar. Cutting the spar introduces a weak point. It introduces flex. In a high G dive, flex means flutter. Flutter means the wing rips off. So the Navy was stuck. They were staring down the barrel of a war with a superior enemy, armed with an inferior plane that took up too much space. The admirals demanded a solution. They sent out a request to the Grumman Aircraft Engineering Corporation. The Bureau request: double the fighter capacity, maintain structural integrity. Do not increase hangar height. Deadline: yesterday. It was an impossible ask. They were asking for a magical object that was solid as a rock in the air, but flexible as a gymnast on the ground. The prevailing engineering wisdom said it couldn't be done. You can have strength, or you can have compact storage. You cannot have both. Physics is a cruel mistress. She doesn't negotiate. The engineers at BU Air looked at the diagrams of the standard overhead fold and shook their heads. If you folded the Wildcat's wings up, they would hit the roof of the Yorktown's hangar. If you folded them back, they would cut into the fuselage structure. There was no angle that worked. The geometry was closed. Every day the solution didn't exist was a day closer to disaster. The Japanese were drilling pilot replacement programs. They were practicing fleet maneuvers. The U.S. Navy was arguing about hinge stress tolerances. The tension in the Pacific was measured in pounds per square inch. The Japanese expansion was expanding at a rate of hundreds of miles per day. The U.S. response was paralyzed by a simple lack of square footage. They were bringing a knife to a gunfight, and they couldn't even fit the knife in their pocket. The system was broken. The manual was useless. They needed a mechanic. They needed someone who didn't care about naval tradition or the sanctity of the uncut spar. They needed a man who looked at a multi-million-dollar fighter plane and saw a geometry problem that could be solved with office supplies. Leroy Grumman was not a war hero. He didn't smoke cigars, he didn't scream orders, and he didn't wear a uniform covered in gold braid. He was a quiet man with a high forehead and the calloused hands of someone who respected the difference between a drawing and a part. He ran the Grumman Iron Works out of a converted garage in Long Island, a place that smelled of machine oil and sawdust. He didn't fight enemies. He fought friction. While the admirals in Washington were shouting about tonnage and firepower, Grumman sat at his desk, staring at a pink rubber eraser. To the Navy, the F4F Wildcat was a weapon system. To Grumman, it was a packaging problem. He knew the Navy's demand, double the planes, same space, was physically impossible if you followed the rules of Euclidean geometry as the Bureau understood them. If we fold them up, they hit the ceiling. If we fold them back, they hit the wall. The plane is too damn big. That was the refrain from his design team. They were exhausted. They had tried every hinge, every pivot, every lever. The overhead fold, the standard method, was a non-starter. It turned the plane into a sailboat with a mast, raising the center of gravity and making the ship unstable in rough seas. Grumman didn't argue. He picked up a paperclip. The paperclip protocol. He straightened one leg of the wire clip. He took the rectangular eraser, representing the wing, and jammed the wire into the side. Not straight in at 90 degrees, and not parallel. He inserted it at a canted angle. A compound angle. He held the eraser against the fuselage of his other hand. He pivoted it. The eraser didn't just swing back, it didn't just swing up, it did both simultaneously. It rotated on a diagonal axis, twisting as it folded, tucking itself neatly against the side of the imaginary plane, like a bird tucking its head under a wing. The leading edge pointed down. The wingtips pointed back. It was origami in steel. Grumman looked at the paperclip. It hadn't changed length. The eraser hadn't changed size. But the footprint, the spot factor, had vanished. By canting the hinge axis, he had discovered a way to make the wing translate through 3D space without hitting the ceiling or the fuselage. Innovation, the Sto-Wing, Axis angle.
Approximately 45 degrees compound. Folded width, 14 feet.
Space saving, 64%. The math was elegant. It was perfect. It was a zero contrast to the clunky hydraulic nightmares the Navy was used to. But an idea on a desk is not a machine in the air. Now came the hard part, the resistance. Grumman took the design to the floor. He told his engineers to cut the spar of the Wildcat, the holy grail of structural integrity, and install a massive diagonal hydraulic pin. You want us to do what? You're going to saw the main beam in half? The shop foreman looked at him like he was insane. In aviation, continuity is strength. A continuous beam can take the G-forces of a 400-mile-per-hour pull-out. A hinged beam is a collection of parts waiting to separate. Every joint is a failure point. Every pin is a potential fracture. The load calculation. The spar carries the entire weight of the aircraft during a 9G pull-up. That's roughly 45,000 pounds of force trying to rip the wings off. Grumman was proposing to hold that force with a single locking pin and a hydraulic cylinder. But Grumman was an ironworks man. He didn't build fragile things. He designed the hinge to be heavier than the spar it replaced. He over-engineered it. He made it so robust that if the plane crashed, the wings might be the only things left intact. He called it the Sto-Wing. They built the prototype. The F4F-4. They installed the mechanism. A small hand crank on the fuselage. No heavy hydraulics. No team of 5 mechanics. 1 man, 1 crank. 30 seconds. The mechanic would spin the crank, and the wing would magically untwist, sliding out and locking with a satisfying metallic clunk. It was beautiful. It was efficient, and the pilots hated it. When the first folding Wildcats arrived at the squadrons, the reaction was immediate and hostile. These were men who lived by the seat of their pants. They felt the plane. They knew that extra weight meant death. The Sto-Wing mechanism added nearly 400 pounds to the aircraft. F4F-3 fixed wing, 7,000 pounds loaded. F4F-4 folding wing, 7,400 pounds loaded. Climb rate penalty. Minus 200 feet per minute. To a fighter pilot, weight is a sin. That 400 pounds meant they climbed slower. It meant they turned slightly wider. It meant that when a Zero was on their tail, they had less energy to escape. They looked at the hinge and saw a bureaucracy trying to kill them. They saw a gadget designed by a suit who didn't have to fly it. Give me my -3 back. I don't care if it takes up the whole deck. I want a plane that climbs, not a plane that folds. That was the feedback flooding into the Bureau. The pilots, the resistance, rebelled. They claimed the folding mechanism was dangerous. They claimed the wings would fold up in mid-air during a dogfight. The psychological barrier was massive. They were being asked to trust a latch with their lives. Grumman didn't back down. He knew something the pilots didn't. He knew the strategic math. He knew that a pilot in a superior plane is useless if he is outnumbered 4-1. He knew that the only way to survive the Kido Butai was to flood the sky. The volume equation. With fixed wings, the USS Yorktown carries 18 fighters. If she is attacked by 40 Zeros, each Wildcat must fight nearly 3 enemies. Probability of survival, less than 10%. With folding wings, the Yorktown carries 27 to 36 fighters. The ratio drops to 1-1. Probability of survival, 50%. Grumman was trading individual performance for fleet survival. It was a cold, hard calculus. He was making the plane worse individually to make the air wing better collectively. It was the ultimate hack. He was sacrificing the great man ideal of the lone ace for the industrial reality of mass production. The Navy brass, desperate for capacity, sided with the paperclip. They ordered the F4F into production. The pilots grumbled. They kicked the tires. They checked the locking pins obsessively, terrified that the Grumman Iron Works had finally gone soft. They called it the Wildcat Squat, because when the wings were folded, the plane looked small, hunched, and ugly. It lacked the grace of the Spitfire or the menace of the Zero. It looked like a piece of industrial machinery, a forklift with a propeller. But the true test wasn't on the drawing board, and it wasn't on the tarmac at Bethpage. The true test was coming in the middle of the Pacific Ocean, where the salt spray would rust the hinges and the stress of combat would test every rivet. As the Yorktown, Enterprise, and Hornet steamed toward a tiny atoll called Midway, their hangar decks were stuffed to the bursting point with these new, heavy, folding fighters. The elevators groaned under the weight. The mechanics cursed the cramped quarters, but deep inside the ship, the numbers were changing. USS Enterprise, Fighter Squadron VF6. Previous strength, 18. Current strength, 27. Reserve, plus 9. The paperclip had done its job. The carriers were now carrying 50% more teeth. The trap was set. The pilots strapped into their heavy hinged machines, still doubting, still angry. They didn't realize that the defect they hated was about to become the only reason they would live to see tomorrow. The brass had accepted the compromise. The engineer had done the math. Now the zero contrast was about to be tested in blood. The ramp was down. The engines were turning. The paperclip was going to war. 1,000 hours. June 4, 1942, 18,000 feet above the Pacific. The radio in Jimmy Thatch's helmet crackles. It's a static-filled scream of interference and panic. But through the noise, the voice of the fighter director officer on the Yorktown cuts like a knife. Many bogeys, bearing 320. Distance 15 miles, Angels 12. Thatch looks down. Below him, the ocean is a sheet of hammered blue steel. Above him, the sky is an empty, blinding white. But at bearing 320, the emptiness is broken. They look like gnats at first, tiny black specks dancing against the clouds. Then they grow. They sharpen. The wall. It isn't a patrol. It's an invasion. A massive formation of A6M Zeros escorting Val dive bombers and Kate torpedo bombers. The Kido Butai has emptied its decks. They are coming to sink the American fleet. Enemy force, 108 aircraft. U.S. defensive cap, 24 Wildcats airborne. Odds, 1 to 4.5. Thatch glances at his wingman, Ensign R.A. Ramdib. They are flying the F4F-4. The paperclip plane, the heavy brick. They are struggling to maintain altitude. The extra 400 pounds of hinge and hydraulic line is dragging them down like an anchor. The engine temperature gauge is creeping into the red. The Pratt & Whitney radial is screaming to keep the heavy airframe climbing. Energy logic. Altitude is life. Speed is insurance. The F4F-4 has neither right now. To climb to the intercept point, they are burning fuel at a rate of 100 gallons per hour. They are sluggish. If they try to turn with a zero now, the wing loading will bleed their speed to zero in seconds. They will stall. They will die. The Zeros spot them. The reaction is instantaneous. The Japanese formation breaks. A flight of Zeros peels off the top of the stack, rolling inverted. They drop like stones, trading altitude for speed. They are sleek, silver sharks diving into a school of tuna. Contact! The first pass is a blur of light and noise. Tracers zip past Thatch's canopy, green golf balls of magnesium fire. The sound of air being torn apart by high-velocity metal drowns out the engine. Thatch hauls back on the stick. This is the moment the pilots feared. He pulls 4 Gs. The world goes gray at the edges. The heavy wings of the Wildcat groan. The rivets on the folding mechanism are taking the full weight of the turn. Every pilot in the squadron has the same thought. Will the pin shear? Will the hinge snap? The wing holds. The ironworks didn't lie. But the plane is slow. Thatch kicks the rudder, trying to bring his nose around, but the Zero is already gone. It looped over him, tight and impossible, and is now slotting in behind his tail. I can't shake him. He's inside my turn. I can't shake him. The radio is filled with the shouts of dying men. The Zeros are dancing. They are looping around lumbering Wildcats, slashing at them with 20mm cannons. The American planes are taking hits. Chunks of aluminum fly off fuselages. Smoke trails begin to streak the sky. Thatch grits his teeth. He jams the throttle through the firewall. He tries to maneuver, but the squat feels like it's flying through molasses. The extra weight is killing his turn radius. He is a sitting duck. Ammo count. 1,400 rounds, guns. 6 times .50 caliber. Fire time. 18 seconds. Another problem surfaces. The Bureau, in their infinite wisdom, added 2 extra guns to the F4F-4, but didn't increase the ammo capacity. This means less firing time per gun, and the feed mechanisms are jammed into the folding wing structure. The belt feeds are tight. They are prone to kinking. Thatch lines up a deflection shot on a passing Zero. He squeezes the trigger. Click. 2 guns jam. The vibration of the heavy wing folding mechanism has shifted the ammo trays. He swears, racking the charging handles. The innovation is failing. The pilots were right. The heavy, complicated wing is a liability. They are losing. One Wildcat spirals into the sea, trailing black smoke. Then another. The Zeros are swarming. There are too many of them, and they are too fast. The tactical deadlock is closing in. The doctrine of individual combat is failing. But then, Thatch looks to his left. He expects to see empty sky. He expects to be alone, isolated, the last survivor of a broken squadron. But he isn't alone. There is another Wildcat there, and another, and another. Because of the folding wing, the Yorktown didn't just launch a patrol of 4, it launched a swarm of its own. The reserve deck park, those extra planes that shouldn't have fit, are in the air. The volume shift. In a standard 1941 air group, Thatch would have 6 planes in this sector. Today he has 12. The density of American fire is double the historical average. The Zeros, used to picking off lone wolves, are suddenly flying into a wall of lead. Thatch keys his mic. He remembers the theory. He remembers the blocks on the map table. The beam defense. Ram, weave now! This is the moment the math changes. Thatch banks hard right. Dib banks hard left. They turn away from each other. The Zero on Thatch's tail bites. The Japanese pilot, thinking Thatch is fleeing, tightens his turn to follow. He lines up his sights on Thatch's fuselage. He has the kill. But he forgot the geometry. By turning inward, Dib crosses Thatch's path. The 2 Wildcats pass each other like scissors closing. As the Zero chases Thatch, it flies directly into the nose of Dib's Wildcat. It is a head-on collision of vectors. The Japanese pilot is fixated on his prey. He doesn't see the second plane sliding across his field of view until the leading edge of Dib's wings light up. 6.50 caliber machine guns, even the jammed ones clearing now, erupt. The Zero flies through a solid cone of copper-jacketed steel. It doesn't just crash. It disintegrates. The unarmored Japanese fighter, filled with volatile fuel, explodes into a fireball that Thatch flies right through. Soot stains his windshield. Kill confirmed. 0. Tactic. Thatch weave. Status. Effective. "It works!" Dib screams. "It works!" They do it again. They weave back. Scissor right. Scissor left. The Zeros are confused. Their superior turning radius doesn't matter anymore. Every time they latch onto a tail, another Wildcat cuts across their path and blows them out of the sky. And here is the revelation. The Thatch weave is a volume tactic. It requires pairs. It requires redundancy. If Thatch had only launched with the standard 18 planes, once he lost 2 or 3, the formation would crumble. There would be no one to weave with. But the paperclip planes keep coming. Every time a Wildcat is hit, another one slots into the formation. The Yorktown is pumping them into the air like a factory line. The sheer mass of metal in the sky is overwhelming the delicate Japanese doctrine. Attrition rate. The Zeros have limited 20mm cannon ammo, about 60 rounds per gun. That's 7 seconds of fire. They are wasting it trying to chew through the armored, self-sealing Wildcats. But the Wildcats, despite the jams, have volume. They are putting thousands of rounds into the air. The probability field is shifting. The battle turns into a chaotic, swirling melee. It is a grinder. The heavy, folding F4F-4s are taking punishment that would vaporize a Zero. Thatch feels a hammer blow to his right wing. A 20mm shell punches a hole the size of a dinner plate right through the folding mechanism. He looks out. The hydraulic line is severed. Fluid is misting into the airstream. The hinge pin is exposed. If that pin goes, I'm dead. He yanks the stick. The plane responds. The ironworks over-engineering holds. The hinge that was too heavy is now the only thing keeping his wing attached. It's solid. It's a tank. The brick fights back. Below them, the Japanese torpedo bombers, the Kates, are making their run on the Yorktown. This is the critical moment. If they drop their fish, the carrier dies. Thatch dives. The extra weight of the F4F becomes an asset. Gravity loves mass. The Wildcat drops like a safe falling out of a window. He screams past 300 knots, the airframe shuddering, the wires singing. He catches a Kate just as it levels out to drop. He pulls the trigger. All 6 guns roar. The Kate shudders. Its fuel tank ruptures. It turns into a comet, splashing into the sea 500 yards from the Yorktown's bow. Then another, and another. The swarm is everywhere. The Japanese attack coordination breaks down. They are being mauled by a wolf pack that is 50% larger than their intelligence reports said was possible. They expected a thin blue line. They hit a brick wall. Japanese attack wave. Broken. Torpedo hits. 0 in this sector. U.S. losses, heavy. U.S. survival. Confirmed. The sky begins to empty. The surviving Zeros, low on fuel and out of ammo, turn back toward their own carriers. Carriers that are currently burning from stem to stern, struck by American dive bombers while their fighter cover was busy wrestling with Thatch's swarm. Thatch checks his fuel. He is running on fumes. The adrenaline is fading, replaced by a shaking exhaustion. His flight suit is soaked. His neck is raw from twisting. He banks the Wildcat back toward the Yorktown. As he enters the landing pattern, he looks at the fleet. The Yorktown is hurt. She's taken hits from dive bombers, but she is afloat. The Enterprise and Hornet are untouched. The air is filled with returning American planes. He drops his hook. He lines up the deck. The landing signal officer waves him in. Cut! Thatch chops the throttle. The Wildcat drops onto the deck with a bone-jarring crash. The tailhook grabs the wire. The plane slams to a halt. Thatch slumps in the cockpit. He is alive. A deck crewman jumps onto the wing. He is carrying a crank. You okay, Commander? Thatch nods, too tired to speak. The crewman inserts the crank into the fuselage. He spins it. With a groan of hydraulics and steel, the wing with the 20-millimeter hole in the hinge, the wing that the pilots hated, the wing that was too heavy, too complex, too civilian, unlocks. It folds. It tucks itself away, diagonal and neat. The plane shrinks. The deck handler pushes the aircraft forward, shoving it into a tight corner of the parking area, right next to another battered survivor. Then another pushes in next to him. Then another. Thatch watches them stack up. He sees the geometry of it. If those wings didn't fold, half of these men would be in the water. If those wings didn't fold, there wouldn't have been enough guns in the sky to run the weave. He looks at the broken wing, scorched and oil-stained. Ugly bastard, he whispers. But he pats the dashboard. It's an apology. The zero contrast is over. The hack has been verified. The paperclip didn't just save space, it saved the fleet. The math of the bureaucracy was wrong, but the math of the battlefield was absolute. Battle of Midway. Result: Japanese carriers sunk. 4. U.S. carriers sunk. 1. History. Altered. The deck crew pushes his plane onto the elevator. As it descends into the hangar, Thatch sees the true scope of the victory. The hangar is full, not with wreckage, but with potential. The swarm survives to fight another day. The ticker tape parades in New York City didn't stop at the Grumman plant on Long Island. The confetti fell for the Admirals, Nimitz, Spruance, Halsey. It fell for the pilots who came back with hollow eyes and holes in their rudders. The mechanic gets no parade. He just gets the next work order. When the reports from Midway reached Bethpage, Leroy Grumman didn't pop a bottle of champagne. He didn't call a press conference to brag about how his paperclip hack had allowed the U.S. Navy to pull a rabbit out of a hat. He simply read the after-action reports, noted the complaints about the hydraulic leaks and the ammo jams, and went back to his drafting table. The F4F-4 is too slow. The wing loading is too high. Fix it. That was his reward for saving the fleet, a demand for something better, and he gave it to them. The Sto-Wing wasn't a one-off improvisation. It became the genetic code of the U.S. Navy. The multiplication effect. When the new Essex-class carriers arrived in 1943, they didn't carry 36 fighters. Because of Grumman's geometry, they carried 100 aircraft. The swarm became a flood. The U.S. Navy could put so much aluminum in the air that the Japanese radar screens simply turned white. Grumman took the F4F, stripped it down, and built the F6F Hellcat. It had the same folding wing, but it had 2,000 horsepower. It was the plane that broke the back of the empire. The ironworks churned them out by the thousands, ugly, angular, folding beasts that could absorb punishment and dish out hell. Every single one of them had that diagonal hinge. The mechanism that pilots had called a death trap became the most trusted component in naval aviation. It allowed the U.S. to project power across the vast distances of the Pacific in a way the Japanese never could. The Kido Butai died because they couldn't scale. Their elevators were too small. Their hangars were too tight. They were defeated by logistics. Final war statistics. Hellcat kill ratio, 19-1. U.S. carrier fleet. 90-plus ships. Sto-Wing failure rate, 0%. Leroy Grumman retired quietly. He was a wealthy man, but he remained a shirt-sleeves engineer until the end. He never wrote a memoir. He never claimed he won the war. He let the pilots tell the stories. He understood the hierarchy of combat. The pilot risks his life. The engineer risks his reputation. One bleeds red. The other bleeds ink. But walk the flight deck of a nuclear supercarrier today. Look at the F/A-18 Super Hornets. Look at the F-35C Lightning II. Look at the E-2 Hawkeye. They are sleek, supersonic, digital monsters made of composite materials and stealth coating. But watch them when they land. Watch them as they taxi to the parking area. The wings unlock. They twist. They fold back against the fuselage on a diagonal axis. The technology has advanced 1,000 years, but the geometry hasn't changed an inch. The ghost of Leroy Grumman is still there, sitting on the wingtip of every jet in the fleet, holding a bent paperclip and an eraser. History remembers the thatch weave. It remembers the dive bombers at Midway. It remembers the courage of the men who flew into the fire. But we should remember the man who stayed behind, the man who realized that before you can win the fight, you have to fit the army through the door. Improvisation defeated doctrine. The paperclip broke the sword.